Okay, the alcohol problem. Apparently, the concentration of alcohol in a person's blood is measurable. That's the BAC level. Recent medical research suggests that the risk capital R, given as a percent, of having an accident while driving a car can be modeled by this equation. R equals 6 times e to the kx power, where x is the variable concentration of alcohol in the blood, the BAC level, and k is a constant of variation. So if you recall, back when we did constants of variation, direct variation, indirect variation, inverse variation, I should say, and joint variation, we had to solve for the constant of variation first. But we had to know information about the other variables. So, suppose that a concentration of alcohol in the blood of 0.04 results in a 10% risk. Well, that would mean that R is a 10, and that's going to equal 6 times e to the k times x power, and x is going to be 0.04, the BAC level. So to get k by itself, we're going to need to bring it down from the power, and before we can do that, we need to move the 6. So we're going to divide both sides by 6 and get 10/6 equals e times 0.04 k power. So now we can get rid of that e. Do you remember how we do that? Right, we natural log both sides, as we just remembered from the last video. Natural logging e cancels and leaves us just with the power. So the natural log of 10/6, and if you want, you could reduce that to 5/3, is going to equal 0.04 k. Now to get k by itself, we're going to have to divide out that 0.04. So we end up with natural log of 10/6 all divided by 0.04 equals k. And that is approximately, when we put that into our calculator, that turns out to be approximately 12.77. I believe it's 12.770 something. So we need to get this answer. So we now have it. We have the k value. Now that we have the k value, what we can do is we can plug that back into the equation up here. So we can say our equation is now actually R equals 6 times e to the 12.77x power. Now we've got our constant of variation. Now we can start solving some questions about this, such as, let's go ahead and pretend, what if x is 0.08? Or in other words, consider the legal limit in most states. What's the risk factor of getting in an accident? So R would equal 6 times e to the 12.77 times 0.08 power. So we throw that directly into our calculator, and our calculator would look something like this. 6e caret starts its own parenthesis, 12.77 times 0.08. And if we plug that into our calculator, what we end up with is 0.166 blah 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 blah. So we're going to say approximately 16.7%. There's a 16.7% chance of an auto accident if you have a BAC level of 0.08. Now, of course, there are lots of other variables in that, and I'm not a scientist, so I'm not going to get into that. Accident, let's spell that correctly. So this is just one more math thing that we can take a look at. Now, on the other side of it, what we could do is we could solve for something like, well, what if R was 50%? What blood alcohol level would give us a 50% chance of getting in an auto accident? So if we put 50 in for R, we can now solve for X. So we go ahead and simplify everything we've got. Now to get rid of the 6, we're going to go ahead and divide both sides by 6. We get 50 over 6 equals e to the 12.77x power. Of course, you could reduce this to 25/3, but there's no need to. We're going to end up using our calculator in the end here. So again, to get rid of the e, let's do natural log of both sides. And natural log of e cancels, just leaving us with the power. So we end up with the natural log of 50 divided by 6, all divided by 12.77. So we can get x by itself. Now, in your calculator, what's that going to look like? Well, natural log button, and that's going to start its own parenthesis. You're going to put 50 divided by 6 and close that parenthesis. And this is all one group already, so we don't need to parenthesize it. Divide by 12.77. And what we find out is that x is approximately, interesting number again, 0.166. Blah, 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 blah. So in other words, it's approximately, let's say, 16.7%. I believe it was 1.6 something over 5. But it was about 16.7%. So at a 16, now what am I saying? That's not a percent, that's a BAC level, isn't it? That would be crazy, you would die. That is a 0.166% BAC. So that's just over the legal limit of the old legal limit of 0.1. That's about double the current legal limit. BAC. So beware, folks. There are risks out there if you participate in drinking alcohol. The other thing to realize is in your homework tonight, you're going to have 2 more of these problems, one where you're going to change the risk factor and one where you're going to change the BAC level. And that is included in the assignment in Teams. So have a good one, folks. Good luck. Stay safe out there, and I will see you soon. Ask me questions in the video conference. Bye-bye.